In this problem, it says the assets in billions of dollars of the 4 wealthiest people in a particular country are 33, 29, 23, and 10. Assume that samples of size n equals 2 are randomly selected with replacement from the population of 4 values. So we identify the 16 possible samples and find the mean of each sample. Then they've already given all the sample means, and we want to find the probabilities that go along with those. So our samples were, let's see, first value is 33, so we could have 33 and 33. Then we have 33 and 29, 33 and 23, and finally 33 and 10 for the samples that start with 33. So if we find the sample means for each of those are going to be 33, 33 and 33. We add them and divide by 2, we get 33. 33 and 29, we add those together and divide by 2, we get 31. 33 and 23, add those together and divide by 2, and we get 28. And 33 and 10, we add those together and divide by 2, and let's see, that would be 43 divided by 2, which is going to be 21.5. Okay, so then we can continue listing our sample. And now I'm going to start with 29 and 33, then 29 and 29, 29 and 23, and 29 and 10. So even though they gave me the sample means, what I have to do is look at how many there are, how many samples are there altogether. And since there's 4 values, we know that there's going to be 4 times 4, or 16 possible samples when we're selecting with replacement. And I'm looking for how many of each of these values are there within that list. So if I look at 29 and 33, again, this sample mean is 31. 29 and 29 is going to give me 29. 29 and 23 gives me, let's see, what am I thinking? 26. And 29 and 10, that's going to be 19.5. Okay. So here's a little trick with this. I could just keep listing them all out and figuring this out. But notice that the 33 and 33, there's only going to be one of those pairings. We don't have to switch the two 33s. That would be the same sample. So we get 1 out of the 16 possible pairings for that. And then 31 is going to come up twice because it comes from 29 and 33, and then also 33 and 29. So that's going to be 2 out of 16, which simplifies to 1 out of 8. So I'm going to look through and see what values we had. So 33, when I see 33 as the sample mean, that probability is going to be 1 out of 16. Same thing for 29. That's 1 out of 16. 23 is also 1 out of 16. And 10 is going to be 1 out of 16. All the rest of them are going to be 1 out of 8. And I'm honestly really just counting on the fact that they didn't have any that weirdly come up to be the same sample mean twice. So let's just double check this. We've got 1 out of 16, and then 1 out of 8 is 2 out of 16. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So that works. So that adds up to what it should be. Oops. Not erase that whole thing. And so those are my probabilities. So now let's take a look at what happens when we enter those and we see that we got the correct answer there. So now what we would do is calculate the mean of the population. And I did that and I got 23.75. So I just added up the four numbers and divided by 4. So that's the population mean, mu. And that is equal to the mean of the sample means. How do I know it's going to be equal to? Because the mean is a good estimator. It's an unbiased estimator. So I know that the mean of the sample means is also going to be 23.75. I can calculate it by putting the X bar values into L1, and L2 would be the probability of X bar, and then calculate one variable stats. With L1 as the list and L2 as the frequency list. So if I do that, then we get X bar is 23.75 for the mean of the sample means. But I don't really have to do that because I know the mean is a good estimator. So now we go to the final step. And so we can see that that was correct. And then do the sample means target the value of the population mean? They do target the value of the population mean. In general, do sample means make good estimates of population means? Yes, they do. They always do. So this is not, oh, in this example it did. Always, we're going to say that. And the mean is an unbiased estimator. So that's why. And that's how you do that problem.